Okay, so we'll have Norman Barker from TileDB. He's going to tell us about cloud native vector data with TileDB.
Great, thank you. I'm just going to share my screen. Thank you for having me. So you should be able to see my presentation now.
Yes,
I'm going to make it. Yeah, I'm going to make it full screen.
Cool. And we need to keep things to 5 minutes to not get.
Yeah, I'm going to be exactly five minutes. So yeah, let's get started in the interest of time. Thanks, Chris. So I'm going to talk about a little bit about who TileDB is, because I don't think many people in this audience know. So we were originally spun out from MIT and Intel Labs in 2017. We've raised over 20 million from world-class investors. And we're currently about 45 people strong in the company. We have a lot of traction in geospatial, telecoms, and farmers and hospitals and other scientific organizations. What is the actual problem? Well, organizations are drowning in a data infrastructure mess. They just have too much data, too many different data sources. You know, SQL, we talked a little bit about Parquet, shapefile, geotiff, it's just too much to handle. And there's too many domain-specific file formats. Everyone's recreating the file format. And so we want to focus more on APIs and having a universal data engine. What does this result? This mess results in low productivity for data analysts and scientists and a huge total cost of ownership for organizations. So what's the secret sauce? Well, with TileDB, you can model everything as a dense or a sparse array. So dense is raster, sparse is like geometries and point clouds. So we're going to go into more detail in a second. So we have data frames. We have a column store. TileDB is a column store. Sorry, someone just took over control. There we go. So we have TileDB as a column store. You can see that at the top, and that maps down into a sparse array and a dense array. So what are the examples? Well, table, LiDAR, SAR, 2D and 3D, so spatial temporal data, time series, and weather and video. TileDB embedded is completely open source. It's built in C++. It's fully parallelized, so very, very fast for read and write. It's a column format, supports multiple compressions, so you can compress each column differently. And we also already had spatial indexing built in, so we have R trees with sparse arrays. We have many, many APIs in like R and Java, C#, C++, and Python. And we also support updating and versioning, so we have multiple writes with lock-free, and we have parallel readers and writers. We also allow you to go back in time, so once you write to an array, you go back to a previous timestamp. So master data is stored as 2 or 3D sparse arrays, so temporal data. I gave a webinar last week on how we work with SAR data, which is complex data, which is spatial temporal. We allow cloud natives to read and write directly from cloud storage, so Google Cloud, Amazon, or Azure, for example, and versioning and time tracking. Let's move on, in the interest of time, onto the actual sparse implementation. So point data, we've long had support for point data, so like LiDAR data, for example, in TileDB, and we allow native float indexing. We have visual indexing with R trees and Hilbert curves, so space filling curves. We have cloud native, so rapid reads and write, versioning and time tracking, and we also support schema evolution. So you can evolve the schema over time, so you can add attributes to your data. You can add columns to your data if you need to. We also have integration with both PDAL and the point cloud library PCL. So how do we do geometry data? So we saw that GeoArrow added a random binary geometry type to their schema. You can do the same thing in TileDB. So you can see that we have an initial implementation already in GDAL. So I went through Evan's merge yesterday, and I was made to copy that into TileDB. We have the same benefits as the raster driver that already exists in GDAL. So you can read both geometries and points and rasters through one API. We're cloud native, we have versioning and time tracking, and we have spatial indexing already built in. And more importantly, the metadata is maintained, so you have a direct one-to-one from the source to the destination. Sorry for the slightly out of sync here on the bullets. So how do we do the spatial indexing? So we have the concept of envelopes and centroids and storing the XYZ. So we already know to store the XYZ directly in the TileDB array. So we already index directly on native coordinates. And the way that we do spatial indexing for geometry as opposed to points is that we store the maximum distance from the geometry centroid to the boundary of the geometry. And we store that as metadata. And that's one fixed value in X, Y, and Z, or X, Y, Z, and T if you wanted to. It's computationally faster just to store the center point of the geometry bounding box. And then we already buffer the bounding box query that we make, the rectangular query, by half the bounding box of the query we make. And then when you get the results, we filter on every geometry. And we maintain interoperability with PDAL and also AIS, so vector location data for point clouds. So you can see down here on the bottom right, we have a diagram. We're going to make an ellipse query here as a geometry query that we buffered from a point. You see all the geometries inside. We actually query on the bounding box, and then we buffer that bounding box by a slight amount. And then on the result, we filter it. And this is very, very fast. We already archive like 10 years of AIS data, and we query that data within a couple of seconds. So what's next? Well, what are our results? We initially tried to be interoperable with the Apache Arrow layer in GDAL because we already have an Arrow adapter inside TileDB, so you can go from Arrow to TileDB and back again. But actually, it was just easier just to go directly with TileDB code. So we have an invitation within GDAL. I'll be issuing the PI this week.
Norman, excuse me, we are coming to the end of our time, so we'll just wrap up.
Yeah.
Thank you.
Yeah, thank you. So geometry specified install is WKB. We support schema evolution, time tracking, and versioning. And we also allow spatial filtering and indexing. And more importantly, we have one API for rasters and geometries. So the future, we're going to have benchmarks for cog and vector. And we're going to have a 3D geometry library built in TileDB, which will be open source. So right now, most geometry queries are 2D. We want to extend this to 3-dimensional. And we're going to have enhanced browser visualizations. And yeah, with that, thank you for your time.
Thank you very much, Norman, for this presentation. And we are